Hey everybody, in this video we're going to talk about the basics of functions. So let's get started. A relation is kind of the most basic idea of what we're looking at. A relation is any set of ordered pairs on the coordinate plane. So anything that you can plot on the coordinate plane is going to have a relationship. And the most basic would be like just a one coordinate, an x and y point. But anything that you can plot on the coordinate plane is going to show some relationship between x and y. So that's kind of what I considered our kind of high level. So maybe we'll call this our relations out here. So relations, anything that you can plot on the coordinate plane. Oftentimes, those relations can be expressed as an equation. And so, if you consider that any point plotted on the coordinate plane, you could have like almost like a scatter plot. Those are all going to be relationships. An equation is going to be a little bit more defined, and that might look something like this. So that will really be kind of a subset within here of your relations that you've got your equations. So kind of consider that a subset of your relations. And then within that subset of the equations, you have your last bit, which is your function. And your function is going to be where every single x, there's only one y value. And we're going to talk about what some of that, how that works and what that means in a minute. But this is the definition of a function. It's an equation where every x can have only one y value. And so we would kind of put that as the furthest piece in here as our function. So you can kind of consider them as subsets within each other. Now, when we look at functions, there's two ways that we can write this. You can see you've got this one here, which is probably the most common, is your f of x function. And this is another way to write a function notation. You'll see this on some exams or maybe some more formal notations, but this is really the same thing as saying f of x, which we tend to write most frequently. And when you think of a function, you kind of consider this is your name of the function. So we might call it f, we might call it height, we might call it area, anything of the function, and we kind of put some letter on it, and that's going to be the same over here as well. This is still the name of the function. Then within that function, we have what we consider our inputs. Our inputs are the values that we tend to put into the function. So what we need to do to calculate something within the function. That's going to be our input. And then the last piece is kind of the whole piece. This is our output. And you can kind of consider this as our output. And what you're going to see is when we do our outputs, it's often also what happens over here, what we calculate over here. What we calculate over here, that's going to be your output. So you kind of consider your inputs. Oftentimes, these are going to be your x values, whatever you're putting into the function. And a lot of times when we consider our outputs, those are going to be our y values. And that doesn't matter, again, which function notation you're using, it's still going to be the same. And we say that this is our y value over here because when we put an x value in, this is kind of like represents y. So typically, like we could even write this function here, or this equation here, we could write that as a function, and we could say, that's going to be f of x is equal to 2x cubed plus 5. So when I put a value in for x, like let's say I wanted to put in some number like 3, I'm going to get 2 times 3 cubed plus 5. Well, this thing equals all of this. So when I put this value in, what I get as a result is going to be my output. So that's why we say this is our y value, this whole chunk, this is our y value. So whether you can kind of consider this side of the equation or this chunk as your y value, that's one way to think of it. But really the basic idea is you put something into your function and then you get something out after you do the computation. All right, so how do we identify what is a function? Well, a second ago we had talked about for every x, there's only one y value. So let's take a look at what some of these things might look like. So one way to identify if something is indeed a function is to do this thing called the vertical line test. And that's really just a way to check. Like if I take a vertical line and I'm kind of checking as I move along all of my x's here, do I ever hit more than one spot on the graph at one time? And here I can see that I don't, so this first one is a function. When we go over here, we're going along, there's nothing here. It looks like it might be getting over here, that there might be some spot where there's two, but if, as we know, as you'll learn more about this type of function itself, this is actually an asymptote. So even though my drawing, it looks like it touches, it actually never touches. And there's an asymptote at the x equals 0 value. So there's actually still no spot where there's two values that that meet up for your x. So this is a function, this is a function, and this is a function. And you probably are going to already figure out where I'm going with this last one, is that right now, okay, here we go. So at any spot along here, I'm going to get two spots for this x. So for whatever this x value is right here, I'm now getting two spots. So this type of graph is not a function. You can write it as an equation, and an equation is a relationship because we're relating these x's and these y's. So all of these things are a relation, but it's just not a function because a function is defined as for every x, there's only one y value, and here we've got two, so this one is not a function. All right, so let's take a look at how some of these things might work for us. So again, we talked about there being inputs and outputs. And so sometimes you might see something where it says, hey, what is f of 4? If f of x is all of this, what is f of 4? Well, we can consider that as our function when x is equal to 4. That's really what's happening. So here we're saying we've got x is all these spots. So what is this function when x is equal to 4? So all I'm going to do is I'm just going to take all of these things and I'm going to replace all of the x's with 4, exactly as I see it. And then I'm just computing or the values from there. So what do we got? Minus 24, 5 minus 24. So that's going to give us a minus 19. So that's what it would be. So if we had f of 4. Now, if we had f of x plus 2, I'm going to do the same exact thing. I'm going to take this x plus 2 and I'm going to replace every single x with x plus 2. So, you can put in anything inside these functions. So I've got 5 minus 2 times x plus 2 minus x plus 2 squared. All right, so now if I want to find it in simplest terms, I just need to expand all of this. And then I've got minus x squared plus 4x plus 4. And as I keep on expanding or keep on simplifying, 5 minus 4 is 1. And then I've got to distribute this negative across here. So I've got minus x squared minus 4x minus 4. And now I just simplify one last step from there. So minus x squared minus 6x minus 3. So there we go. So you can put a 4 in here. You could put an x plus 2 in here. You could even, if you wanted, you could put a star inside there. It really doesn't matter. This is just saying, hey, I'm putting some symbol, something in here. This is my placeholder, is our x's, and whatever I want to put in there. I want to put in 4. I want to put in x plus 2. I want to put in a star, a cookie, whatever. I'm putting something in here, and then I'll get something out. So that's the idea of what's happening in there. All right, so when we have functions, we have what's called a domain and a range. And quite simply, the domain is every single x value possible. Every possible x value for the function. And for our range, that is every possible y value for the function. Excuse me, y value for the function. And, a little kind of mnemonic or way to remember this. This is one way that I remember it, is that in the alphabet, D comes before R. So D and X comes before Y. So that's how I remember that. Domain goes with X and range goes with Y. That's just a little way that I remember it. That might help you if you're ever stuck or you get stuck on which one belongs to which. Now, there are a few different ways that you can write this. I got this from our Hayes textbook, but you could write it in set notation, where this says x such that, this line here means such that. Now, if you're looking at probability, that line might mean something else, but in context here, this means x such that x is going to be greater than or equal to 3. And you could also write it as an interval. Sometimes people write interval notations as this as well, where we would have infinity, or sorry, negative infinity, not infinity, negative infinity and 3, and we use a square box. So this implies inclusion. This implies not including, because you can't ever get to negative infinity. Oh, sorry, this would be greater than 3. So I've got that backwards. X is greater than 3. So we would have to have 3, and there's the inclusion, and it's going to infinity. So sorry about that. But X is greater than 3. So it's going to include 3, greater than or equal to 3, and it's going up to infinity. We can't ever get to infinity, so we put a rounded bracket, which means not inclusion, but everything up to infinity. If you did it on a number line, you do a closed circle there, so that way it implies that 3 is included and everything bigger than that. Or, of course, you could just write it out. Similarly, here we've got x. We've got x such that x is less than 2. So now this would be similar to what I did up above. Now I've got negative infinity because it's going down to that, and 2, but I'm not including 2. Notice this one doesn't have the equal sign underneath there. So then I'm not going to include 2, so I leave a rounded bracket. And in the number line, I've got an open circle here because I'm not including 2. You put a closed circle if you're including the number, an open circle if you are not including the number. Here we've got kind of a combined interval, or a combined set notation where x is between these two numbers. If we wanted to write it in this parenthetical form, we've got our negative 2 not included, and then 1 which is included. So this is another way, again, that you could say that, okay, I'm not including negative 2, but I am including 1. And over here we can see we've got the open circle, so we're not including negative 2, but we are including 1 because it's got a number there. And finally, you could do this here, where you've got it kind of broken up, going in opposite directions. That one, you would have to kind of do 2 sets of parentheses. That one probably is not going to be as useful. But if it's going to be less than or equal to 0, you're going to be going to negative infinity and then 0. And then that's going to be a union with, let's see, we're going greater than 4. So we're going to have 4 comma infinity in a round bracket there. So that's kind of saying this piece right here. using these bracket notations. This union means or. So this thing or this thing. And so you can do that. So, and then of course, there's always the one where we say that you could have, if it's all numbers, that's something that we haven't included. Well, we'll look at that in the next one. We'll look at what that might be here. So there's one other thing that I did not include in here. These are just kind of different set notations or interval notations that you could use, but that's not, you're not limited to these. There's other ways that you can see that, which when we look at this example, you're going to see how some other ways that we might write that. So we've got our set, or our two examples here, and the first one says, hey, let's find the domain and range for this thing. Now we've got a closed circle here, but there's no arrow. This has got an arrow implying that it's going to continue on that way. So here our domain is going to be limited because we're going to go from negative, or we're going to go from 8 all the way this way to infinity. So x has got to be less than or equal to 8. I like doing that notation, the interval notation. And the range here is going to be everything bigger than or equal to -2. So here we see this is the lowest point, so everything going up. So the range is going to be y greater than or equal to -2. Over here at this parabola, we've got our domain. So we want to consider what are all the possible values. And we know for a parabola, we can put x values going on to infinity. So in this case, we could just say x is an element of all real numbers. And that's the symbol for all real numbers. So it's good to know that symbol. And then our y, or sorry, not our y, our range. Our range is going to be everything bigger than -1, because that's our lowest point. So y is going to be greater than or equal to -1. All right, so this will kind of be our last bit that we're going to talk about. So let's state the domain and range of these. So let's assume you don't have a graphing calculator. Now I've got the graphs down below here, and we'll look at those here in a second. But let's say you have to kind of just do it a little bit of analysis of these functions and say, well, how do I know what to put for my domain or for my range? So I have to look at this, and I have to say, or I have to consider, what are possible values to make a square root function? Well, I know underneath here, everything has got to be a positive number. It's got to be 0 or more. So in this case, x plus 3 has got to be greater than 0, because I can't take a square root of a negative number. And actually, it's going to be greater than or equal to 0, because I can take the square root of 0. Square root of 0 is simply 0. So what values of x is going to make that happen? Well, if I subtract 3 from both sides, x has got to be greater than or equal to -3. So there's my domain. And what am I going to get for my range? Well, my range is simply going to be everything that is positive, because when I take a square root of a number, it's always going to be a positive number. So that just means y is going to be greater than or equal to 0. And finally, what about this one over here? This is going to be what we call a rational function. And this one says, hey, we've got something down here in the denominator, but we know that we cannot divide by 0. So x plus 2 cannot equal 0. So what does that mean for x? That means x cannot equal -2 if I subtract it from both sides. So my domain is quite simply x does not equal -2, or you can say something like x is all real numbers excluding number -2. And then our range, our y value, well, if you know about these functions, These have a funny looking shape, but let's even just consider what's going to happen if I pick uh, large numbers for x. If I pick really large numbers for x, I'm going to get like 1,000, 10,000, a million. If I've got 1/1,000,000, that's going to give me a y value that's really, really small. It's going to be really close to zero. So that thing's going to be approaching zero from the positive side. We kind of say that, and we'll talk more about that when we get to a limits equation or a limits lesson. But if we take this thing, we take a really small number, so a negative infinity. So that's going to be like negative 10,000 plus 2, so negative 999,998. Well, that's also going to be approaching zero, but it's going to be approaching zero from the bottom. So we know here that we're not going to be getting to zero. No matter what we do, we're never going to get to zero. The only way we get to a zero with a function is if we have the numerator equal zero, and in this case, that's not going to happen. So we're going to approach zero, but we're not going to get to zero. So x, or sorry, not x. So in this case, y cannot equal zero. So there's our domain and range. And if we look at the graphs of these things, here we go. Here's our square root of x plus 3. We can see here at -3, -3 is where we're starting, and it's going up here. So for all of our y values, it's going up, and it's going to keep on going up. Even though it looks like it's going slowly, it will hit every single y value going off that way. And this equation here, here's our 1 over x plus 2, and we can see for our y values are all the ones that go up and down here. We just have this asymptote right in here in the middle where it does not get anything, where there's no y values. And our x value, we also have an asymptote here at -2. So we've got our domain and range by putting some limitations on those. So that's the very basics of functions. I hope this helps, and I will talk to you in the next video.